Hello, everyone. We're here for another workshop. I hope there's folks here. If not, I'm just going to talk to the recording. I started just a smidge early just to let everyone find a chair. There's some in the back I see. Okay, cool. Yeah, so today we're going to talk about some Gen AI stuff, but I really hope you're a Cassandra person because this is geared towards you. If not, you're going to get something out of this. That's not going to be a problem. There's a lot to talk about with Gen AI, isn't there? And if you're here, shout out on the old chat. I appreciate it. All right. Okay, let's get moving here because I got a lot of slides and a lot of demoing to do, and let's just get to it. So today we're going to talk about those Gen AI success problems when it comes to building building with Cassandra, and this is for Cassandra teams. So just a little bit about I put this slide up a lot, and I think it's important for you to see. This is you, maybe. Are you feeling, stressed out, feeling behind? That boss that's like, hey, we need an AI. If that's you, you're in the right place today. And this is my safe harbor comment. And by that, I mean, we're all kind of feeling this. Let's just be helpful and work with each other. And, this is a community of users, right? Communities, we stick together and we help each other and we make things work together. And it's always been my experience in technology, especially when technology goes through these ripples like they are now, that we all depend on each other to get through without, getting them scarred and beat up and destroyed. And this is no different from any other time. So it's not a place for someone to say that they are more superior than someone else, or that people are falling behind and we leave them behind. If you see someone falling behind, ask them, can I help? And if you're falling behind, hey, ask for help. We're always here for you. And of course, let's do this together. So that being said, let's move on to the content. So today's agenda, I'm going to do a 101 level of generative AI. And if this is something that's new to you, hopefully you'll get something out of it. If it's something not new to you, hopefully you'll pick up some nuggets along the way. I've been working with generative AI for quite a while now, for about over a year now, and especially around Cassandra. I've learned some things, but I've also figured out the code. It's not as crazy as you think. And I think it's important that we have these discussions around this idea of like, okay, here's the tool, here's all the different parts, and this is how it works for you. It's not magical, it's not mystical. It's just another tool. And then I'll go into how Cassandra fits into this whole process. And it does. And you, being a Cassandra team or a Cassandra person, you've got an opportunity in front of you, and I want to help you with that. And then finally, we're going to go through some more practical stuff like that 3 steps to production. And what I want to do is go through, there's some hands-on, some practical information along the way. It by no means are we going to build anything today. We have an hour, but at the end of this whole thing, I have a little poll that I want to ask everyone. So just keep in mind when you're watching this, what other topics? I want to do one of these maybe every couple weeks and dig into each topic, but I want to do the ones that you need. I've done this for years, and I think this is the right way to go. I can come up with topics, trust me. But as you're going along through this content, if you say, hey, can you dig into that more? Great. I want to hear about it and I want to do it. So just keep that in mind as we go along. So let's begin with the basics of generative AI. And that conversation would not start with just AI. And I think this has been a problem that we've had for years, is we have many flavors of AI and it kind of gets blended together and mushed into a ball. And they are very different. AI is not new. If you want to get an opinionation from an AI person, they're going to be like, wow, this has been around for a million years. Well, it has. I mean, AI was as soon as computers became a thing, everyone started talking about AI. That was a long, long time ago in a galaxy far, far away. But there are definitely like some buckets for that. So starting with decision support. And This has been around for a long time. It's actually one of the first things around AI was like, hey, how do we have a smart decision machine? And it's more than just to say a state machine where this input makes it do that, that input makes it do this, that sort of thing. It's putting some sort of intelligence around decision making. The ultimate thing would be like autonomous driving, which if you're driving a Tesla right now, you probably got it for free right now. Yeah, but you know where it is right now. It's not 100%. I would not trust my car to drive me around. It's cool for cruise control, but that's the kind of that decision support system, the AI. It's not intelligent as so much as it's making good decisions, or it's trying to make good decisions. And that's been around for a while. Now, recognition, like facial recognition, name recognition, all these different recognitions, those have also been around for quite a while too, in various forms. Facial recognition has been around for quite a while. Ask any government agency. But the recognition part has been kind of a foundation for what's happening in generative AI. And I'll talk about that in a minute. But that's been pretty well established. Now, the one that we've probably all been exposed to the most in the past few years is predictive. And predictive AI is what we would normally call like machine learning. Like, how do I get you to buy one more thing? And that's the inference engines, that sort of thing. Like, you take this training data, you figure out what everyone's buying, and you try to create a model, and then you put it out, and then when someone goes into their shopping cart, you're like, but wait, have you thought about this? That's predictive AI. And it is cornered around a lot of that ML, the ML ops world, ML. And predictive has definitely been the dominant version of AI for years and years and years. And it's because it actually makes money. That's important, right? Or at least in some places it has. I would say that Google is Google because of predictive AI. They know how to put an ad in front of you really quickly, and that makes them bazillions of dollars. So here we are. The next generation is generative AI. It's not new, but it has a step function. Generative AI has been something about, and of course that means creating new content, creating new data. And that has been around for a while, but it just hasn't been super useful or very effective. And that has just kept it pretty much in the back room or in academia. And it took good old OpenAI and ChatGPT to really blow us away. And it happened fast. I think everyone remembers that's in this industry can remember like when ChatGPT came online, it just changed everything. Everyone just lost their mind because you could go in and have this conversation with this thing and it knows stuff and it just does stuff. And we got a little carried away. We're like, oh, that's it. That's the end of the universe. We're done. AI is going to take over everything. Yeah, not really. But it is really, really helpful and useful for a lot of applications. And that also includes not just text, but also like DALL-E, the building images. And if you use Midjourney or something like that, Stable Diffusion, those are really cool because that's creating an image. And now that's also creating meltdowns like the Sora videos of creating, like from taking text and making a movie out of it. There's a lot of people having a little existential crisis, but that's all generative. And it's based on this idea of a model. And the model, building the model, this is what we all talk about. Like when we talk about, hey, what about this model, GPT-4, blah, blah, blah. Those models are all built for there's a couple of different flavors of models. There's these text-based models, which we are familiar with in chat. And it takes an input like, hey, how would you describe a cat? And it outputs something like, hey, a cat is a small domestic animal, blah, blah, blah. And it's great as a demonstration for sure, but it also gives us an ability that we haven't had before, which is we can do like natural language communication with a computer. And if you've used something like Siri or something like that, or Alexa, it's like it picks up a few words, not all of them. And it's great that I can make a mistake. I would say, how would you describe a kitty cat, or use a different language or whatever, and it figures it out. So that's a big step function in what we can do with these models. And then for images, a different kind of model. These are built on this idea of building up images, but it's still in that kind of a generative AI world, but it's a little different from text. Images, video, audio, they're all in this same class of generative models where they build up the information, but they take one thing. And the basis of this is taking an instruction. So, and I'm going to use instructions. Instead of saying text prompt, I'm going to say instruction. They take instructions. And what they do is they encode it. So they break it down into pieces, and then you hear this word tokenize. Tokenizing isn't like just every word. It's like phenomes, and there's just a whole branch of tokenization, but like what that is. Not important for today, but I want you to see this as like, okay, this is a machine, a black box type thing, but it's not too mystical. There's no magic going on here. It takes instructions, encodes those instructions, and then passes it through a really complicated bit of matrix math, decodes it, weighs, and does predictions, and then it gives you output. That process is really intense. It takes, this is what you all see now is NVIDIA's stock is through the roof because it takes the biggest NVIDIA cards they have to do this sort of thing. And it's not just running the LLM, it's the training. And that's the next slide. But just understanding that this is more or less a machine of some sort is you takes instruction, does some work, produces output. That's what all these are. The GPT-4s, the Llama 3s, Mistrals, they all do this in some way. And most of them in their own way. But the killer app is this, which is the training. And so that's where you see like, what's the difference between GPT 3.5 and 4 and potentially 5? Mostly it's around how much training they do. Now we won't go into like how it's being trained. What I would like to talk about is what it's being trained with. And this is what makes it a useful machine for us, is that the LLMs are being trained with information like, like how people interact with each other when they help, like Stack Overflow, the information from an article. And this is a really important point, how people in specific roles respond. And we'll get to that in a minute, but because there could be different responses from different roles. And that's something you can encode and important. And then, code examples is another thing. It pours a lot of information, but also a lot of the navigation of information into these models and these huge neural nets. And what we get out of it is a thing that could do not only intelligent-ish responses, I say ish because there's some moments, but also some reasoning, like how things come to where they are. There's some really interesting videos out there from some of the founders of OpenAI that talk about how they're actually encoding a person's role or how they respond to something into these LLMs, which gives it a flavor, that reasoning. Like if you were to ask yourself, hey, how would you solve this problem? You'd go through these steps. Well, that got encoded into this LLM, and we could use that to our advantage. That's kind of cool, and we will in a minute. And this is a great slide for you to keep in mind all the time. I've talked to lots and lots of Cassandra folks, lots and lots of IT folks, and there is a level of magical thinking going on around LLMs. They are not magical. This is not C3PO. It's not going to just do, it doesn't have sentience, and it's not universally intelligent. You hear a lot of that talk going on. Like, is it intelligent? No, it's AGI. And artificial general intelligence, not even close. But the things that you don't want to do are the things I'm listing here. Like, it's not a replacement for Spark. Spark has this use cases that LLMs will never be able to do, at least not in the current iteration. And then probably the thing that's most important to understand is precise numerical communication, numerical calculations. Adding up a bunch of numbers or doing a math problem is super hard for an LLM. And it's just based on the fact that it's giving you probabilities. It's not like writing a Python program to add numbers. It's not that. As a matter of fact, LLMs can write a program to do that and will if given the choice, because that's just not something that's inherently built into an LLM how it can do. I put some other things in here like these real-time high stakes decision making, just because it's based on probabilities. You do not want to make a life or death decision, and at a minimum, do not trust it with your money. Right now, that's just not a good idea. And the software tools, it's never going to. These are built to replace things like a CAD software or something like that. And then finally, this long-term data storage, they do encode a lot of information, but they're not a replacement for a database. And maybe in the future they will be in a lot of ways. Who knows? Lots of speculation. But the thing is, it's really expensive to run an LM. And that's probably one of the reasons that all these things are really not a good idea, is because an LLM is probably one of the more expensive things you're going to use in your infrastructure at this point. Because when you have that parsing of tokens, and then it does the work, and then it outputs the tokens, all of that takes a lot of GPU. Of course, GPU is the most expensive thing we can have in our data centers at this point. And it's just not efficient. So it's best to think about an LLM as a tool that can do a certain thing that you want to minimize the amount of traffic to, and just use it the best way possible. It's not an everything tool. It's not the hammer for everything. So there you go. All right, moving on. Now digging into using the tool, and this has been a thing that I've been poring over. Tons of YouTube videos, tons of articles. Like, what is this? And you probably have heard this about a billion times, and it's just annoying. This whole thing of prompt engineering or prompting. It's a thing. It's a thing. But the reason why is because whenever you think of them as if you're using a function like a Java function or a Python function or something, and it has parameters, you use the parameters to get the output you want. And prompting is that. And I paraphrased several comments, but this is the best way I can describe what prompting is: steering a language model towards the desired output without altering its internal weights. So you're influencing the model to go a certain direction. There's a big asterisk on there, and the asterisk is changing the internal weights or altering the internal weights is this thing called fine tuning. Different topic, whole different thing. But that is something that people can do, and what it does, it just tweaks it a little bit. So fine tuning tweaks things so it goes a certain direction. But let's say without fine tuning, and fine tuning is a hard thing to do. So what if you just want to use the model right out of the box? Well, cool. There's a plan, and it's formula for how you create the prompt. So I think this goes into like how it was built. So you have this persona, context, task, an example if you can, and a format if you can. And this formula I put into like an actual, let's walk through this. So I start out with a prompt. I say, you're an Apache Cassandra expert. Okay, so now what we've done is we immediately put it in the mode of like, okay, I'm going to weight things based on this role that I have. So instead of giving you answers for like Postgres or something else, it's like, nope, I'm an Apache Cassandra expert. And then this context is you are consulting with teams to provide advice. So, oh, I'm a consultant. Okay, this is making it. And these are actually changing the way the output works. You can play around with these and see how it works. And it's fascinating how it does really make that difference. And then the task. And the task is, what do you want it to do? Your job is to create a runbook for decommissioning a node in a cluster. Okay. And that's something it could actually do. We'll look at this in a bit, but GPT-4 can do this because that information is encoded in there somewhere, but we can make it better. And then finally, I provide an example, like this is what I want it to look like. They have the precondition checking each step instructions, checks each step, and then post decommission checks. And then I say I want it in Markdown. That's the format. And you can say I want it in JSON or whatever. And mostly, like any LLM will comply with all those things. It'll try to do that. What's funny is things like some LLMs prefer XML over JSON. Okay, but in general, this is how it works, right? Now, prompting has gotten a booster, and you've heard this enough too, RAG. Like, how does RAG fit into this whole prompting thing? I'm glad you asked. And it's really just creating context, real-time context. So when you say, hey, what are compaction settings for Cassandra 3.11? That's really specific. And that question, it's a good question to get an exact answer on, because if you're using, say, Cassandra 2, those are different. And so you'll see, like in RAG, that they bring out these things, like you see that the vector database is being used in that way. You don't have to, but we'll get to that. But using a vector database, what it does is it tries to find context, a similarity search. Oh, Cassandra 3.1, 3.11, compaction. And a properly vectorized data set, like the whole docs for Cassandra, would say, oh, I know where that is. And it would retrieve the document page for compaction settings for Cassandra 3.11, and then use that as a context. So whenever you say our previous prompt, where we say, hey, you're an Apache Cassandra expert, here's the context, which is a whole context of is page of docs on compaction settings for 3.11. How do I do this? You know, how do I do compaction, or what are the compaction settings? And we send that to the LLM. So this big block of text, and then lo and behold, we get a response, which is really nice, nicely formatted. Maybe I want it in Markdown or something like that, like a table of values. But it's not making anything up at that point. It's taking all that information from the database and inserting it into our prompt. So this is the retrieval, that's the R, the retrieval, is augmenting into the LLM, and then the response is based on that. That is a really useful tool. And we'll find out lots of cool ways to hack on that. It doesn't always have to be one thing. You could do quite a bit with this, but really it's about making sure the LLM has enough information to give you a reasonable response. And one of the final topics on LLMs, which I personally, this is one of my personal things, I love these, is using tools. Now, you may see them called functions. The industry has started out with OpenAI. They released GPT functions, or function calls, last summer with one of their models, with GPT-4 and 3.5. So those slowly got morphed into tools, and now most models support what they call tools. And the LangChain, LlamaIndex, they call them tools. So we're just going to use that word. And so what does that mean? Well, whenever you make a call to an LLM, you can also embed a list of tools that it has access to. So for instance, if I want to add two numbers together, this is really simple. Like I said, an LLM is not super good at math, and you don't want it to have to go off and do math, but I know if I wrote a program to do it, then it would be good. That's the right way to do it. So what I do is I say, when I ask the question, I also pass it a list. Hey, here's the tools. And what you say is, I have a function called add numbers. Here's a description, takes a list of numbers and adds them together. The LLM can make a reasoning decision, say, oh, you want me to add numbers? I have a tool for that. And the response will include a tool call. And the tool call says, hey, look, I need to do this thing. Here's call this add numbers function. Here's a list of all the parameters, these 20 and 40. And then inside your LangChain has support, LlamaIndex has support. This is really widely supported. It will make a call to that program that you've added. And it's a little complicated. I would love to do some content if you want me to do more on this. I have more to talk about, but it's a basic thing. It just runs whatever arbitrary code you want, returns that value. Now you can either return it directly to the user, or you could pass it back through the LLM. So it spruces it up a little bit, makes it look nice. It says the answer is 60. And you could trust that because it went through a tool where it's deterministic, instead of the LLM just making up a response. It probably will say 60 because that's a pretty easy one. But if it's something more complicated, like accessing a database, maybe a tool would be a better choice. So that's that on LLMs and the basics of GenAI. I went through this pretty quickly, although I did burn through 24 minutes. I feel like it was important that we get kind of a baseline here. And again, keep in mind, if you want me to dig into any of these topics, I would love to do that in a future workshop. So how about Cassandra, our favorite database? How does it fit in here? And that's a challenging question because Cassandra's been around for a while and has definitely proven itself. I mean, here, this, right? Cassandra is not disputed as a scale leader. And how does it fit into this new world of Gen AI? It is a database and it has data. And just thinking about just more openly, like that's if you're going to work with, say, RAG and things like that. LLMs are great for communication, but they just don't know a lot of things. And we've put a lot of our important data into Cassandra. If you're listening to me now and you have a Cassandra cluster somewhere, chances are that data is pretty critical to your business. So how could we use it? Well, you have choices, and those choices are, and I think this is a good thing for everyone to understand, is that we've gone down the path of like, ooh, to do the new thing, you have to upgrade. And I'm here to tell you, no, you don't. You can. There are things to do. So if you want to stay where you are, if you're using Cassandra 4.1 or less, and you want to do some Gen AI stuff, cool, we can do that. And same with DSE less than 6.9, and that's just because there's going to be Gen AI stuff built into that afterwards. And of course, Astra, if you use regular classic Astra, that's just Cassandra as a service, that doesn't have vector support or anything Gen AI on it, you're still cool. You can still do stuff. And actually, it's pretty useful. Now, if you do want to go down the path of an upgrade, really what you're asking to do is, I want to run a vector. I need to do vector search. And that's going to be Cassandra 5 or greater than DSE 6.9, and then Astra vector for that. And of course, if you have a new project, that'd be a great choice. You just want to start doing it. But you do have a choice. And I think this is this thing that I wanted to make sure that everybody realizes. You don't have to have vector to do RAG. And I'm going to say that again. You do not have to have vector to do RAG. That is not a requirement. Okay, that opens up you to a ton of use cases for Gen AI. That means that you can use that retrieval part of it a little more natively with whatever Cassandra installation you have, with the data you have, to do some really cool things. I use an example here. Chatbot. Let's say that you have you're in e-commerce, you need to do a chatbot with your customers, and that's classic. That's a hello world for Gen AI. It's chatbot. So what if a customer says, "What did I buy last week?" That does not take a complicated bit of data engineering to make work. What you need to do is just have a query that you probably already have, where I go into the custom orders table, look up the user by ID, and I do a range check on their order dates, and I return back all the orders. Now, I build a prompt that says, you are a helpful customer bot, and the customer is asked for when the customer asks for their orders, here's the data, and then provide this back as a useful table in a chatbot, and you kick that through the LLM, and it gives you a response back in the chatbot. And it'll probably give you some super wordy response like, "Oh, you bought 3 things last week." It won't just say that. It'll say a lot. But at no point did I use vector for that. And it's just a matter of retrieving data and giving it, you're wrapping this data, which is just a hard number probably, or a part number or something like that, around, you're wrapping an LLM around it to make it more human. And it's a really cool use case. Think of the things that you could do with that. I use LLMs for that purpose. I want to be able to communicate and in a way that's a little vague, but also I want to be able to get information back that it kind of gleans out meaning from it. And LLMs are good for that. The key is data, and we'll get into how we can make that work. So the upgrade, Cassandra 5, DSE, DataStax Enterprise, DataStax Astra, that is doing vector. Here's what's happening. It's using JVector, and JVector is a really cool project. It's Jonathan Ellis has it in his GitHub. I have the link there. I didn't put it in the links. I will. I'll put it in there. JVector is getting a bit of love out there. Not a bit, a lot of love. It's probably one of the top Java. It is the top Java trending project in GitHub. It's being used by multiple projects now. It is getting a lot of press, a lot of pickup from researchers. It's really one of the best Java libraries out there for this type of thing, but it's also one of the fastest libraries, period, for vector search. And yeah, it's not written in Rust. Sorry. It's using a lot of really cool techniques that are built into Java now. Modern Java has some really neat things when it comes to vector math and working with SIMD and that sort of thing. And JVector uses all of it. And as a result, it's made vector search in Cassandra, all flavors, very interesting. And it's cool because once again, we're leading the charge. And this is going to work at highly distributed highly distributed systems that we use. The core part of JVector is scale. Cassandra is about scale, petabytes, terabytes, whatever. JVector, Jonathan, when he started going down this path, realized that the libraries out there that existed really weren't built for scale. They were built for a laptop or very small use cases, 1,000, 1 million vectors, that sort of thing. What happens when you have 1 billion vectors, 1 trillion vectors, that sort of thing? That's the Cassandra problem. This is a problem we've been solving for a long time. Nothing new. And here we go. So it's pretty exciting. I'm excited about it. And what it does, in a nutshell, is it adds to the data model for Cassandra. So it adds a new type called vector. And a vector is just a float with some dimensions. And the dimensions, now this is a 5-dimensional embeddings. I really doubt you'll ever find a dimensional embedding at that size. Most of them are in their hundreds, some are in the thousands. Vectors are, again, a different topic. I would love to cover it if you want me to. Let me know. I have a survey or a little poll at the end there. You can tell me what you like. But vectors are beasts. They're big numbers. And that's why you need a specialized indexer. But in this case, we'll use 5. And then you create an index. This is all built into the way Cassandra does indexing already. It's using a storage attached index already. And then you could do things like, you could do this ANN, which is approximate nearest neighbor searches on, you could give it like, here's a vector. What's close to this? Vector space stuff is really interesting. That's how you find is this a hot dog or not a hot dog? Pictures, that sort of thing. But whatever you embed into it in your vector, you could figure out what's similar or close to it. Words, pictures, audio, whatever. And really interesting search algorithm. And it's funny because there's a lot of use cases that have nothing to do with GenAI too. But this is what it does. And when you couple this with some actual hard data, so for instance, with my document, you can find a vector embedding model that will give you semantics of the document. And then you can also store the document alongside it in Cassandra because it's a Cassandra database. Think about in this case, give me everything from the product table. Yeah, thanks, Aaron. Aaron Platz, he's already telling me, he's like, you used the hot dog example. And I told him I never would again. And he's telling me on chat that I did it. But it's such a great example. If you don't know what I'm talking about, go watch Silicon Valley. So anyhow, using vector search in a non-GenAI thing is also a use case. Might be worth the talk too. So that's something you're interested in, let me know. And now with a vector, now this is that thing that I talked about. This is what makes it happen. And building hybrid data is cool because a lot of times you need to find something out there, right? And you don't know where it is. And you have this is that fuzzy search. It's not an exact search. So you're not saying, where picture equals hot dog. It's kind of looks like that. And you could use that with your existing data, say product tables, your product data or metadata around a picture or maybe even documents. That's the classic use case right now is go find my documents. But it's going to give you fast access to context that you can put into your prompt, drop it into LLM. And that's real-time data too. The other thing that's really cool about using Cassandra in this use case is real-time, right? It's, say a customer is in the middle of filling a shopping cart and they ask a question about their shopping cart. No point is that in an LLM. The LLM is unaware. So you need to say, oh, dump the contents of the, you are a helpful shopping bot. Here's the contents of the shopping cart. The customer has questions about this and here's some context. Great. And that's real time, right? And that's probably a use case you could do quickly and easily. Yay, team. The thing that makes it work in this case is that real-time stuff. And this is where JVector, here's the slide that everyone's going to like, oh, architecture. No, this is some, this, you should just look at this as like, wow, JVector is fast. Well, yeah, because that's the way it was built. So it says Astra DB vector. That's what's running in, that's what's running this particular one. Yep, super fast. And JVector is built to do this, these really fast search lookups. Now, if you'll notice, these numbers aren't like single digits. We're not there yet. No, vector search is a heavy thing. And so it takes some work, but we're getting faster and faster and faster. And this is something that is being worked on continuously all day. Great discussions. Hopefully, I think we're going to see more talks around JVector out there about how we're actually making it faster. We'll get there. But the thing to remember is if you're using like a specialty vector database, it's just not differentiated. As a matter of fact, it's probably slower than anything that Cassandra can do. So yeah, go team. Okay, we're at the point where now I got to play around with my keyboard and let's dig into like how we can actually do this. All right, you want to do this. You want some steps. Like, give me some practical stuff here, dude. I'm here. So first thing is identifying opportunities. And this is something that I've worked with a lot of users out there on. And I think this is the first step of the crisis of GenAI. It's like, what do we even do, man? I'm not OpenAI. I get it. It's not that complicated. So let's just take a breath together. It's not that complicated. We can do this. And you're going to pick your path. First things first. Do you want to use your existing data in Cassandra, or are you looking for do new things with vector? That's important. Like, where you want to start. And staying where you are is probably the right choice to get going. I've worked as an IT consultant for years and years and years, which means I got to go in and tell you how to do it and I walk away. Great job, by the way. But the thing that I always see is there's always way more excitement and hype about doing the thing, and the plans get ridiculous and scope creep immediately, and then it never gets built. Start with something simple, really simple, and get your success, get your feet under yourself. GenAI, this is that panic is going to be better. You're going to understand so much by just doing something simple, like how an LLM works. I'll tell you one of the biggest hurdles you're going to go over is your legal team. When you say, we're going to put some customer data near an LLM, I'm just going to tell you right now, that's a fun conversation, but one that needs to be had. And there are, of course, plenty of ways to mitigate that. But and I'd love to talk about that if you want. But, this is, I'm going to say stay where you are is probably a good first choice. But what are you going to do? Like, how do you want to do this? Now, because I know this is a problem, I actually built a project. And I have this, I'm going to see if I can share the link on here. Hold on. Go into my little calls to action. Now I put the link up and hopefully it's super simple for you, but it's the thing that this does. And so I'm going to do some hands-on here in a second. So what this does is it's a Python program that will go use OpenAI. So you put in your OpenAI key. If you use local Apache Cassandra, you just put in the IP address of the nodes. It's like one of the nodes. If you're using DSE, same thing. If you need a username and password, use that. But what it does is it goes through, it queries the entire schema, sends it to an LLM like OpenAI. You can use many. You can use any LLM. You can use a local one if you want. But it does some prompting and pulls out a report and says, oh, here's what you have in here. It's not magical. It's not anything revolutionary, but it sure gets you started. And as a matter of fact, let me show you the project here. So I'm going to share that screen. Here's a hands-on part. All right. I want to do a tab. There we go. Now, this is my GitHub project. And there's a few things in here that are helpful for you. So first of all, there's the getting started, but and it walks you through. It's just a simple Python app. The report, and this is generated by GPT-4. I used my killer video schema, which some of you are probably familiar with, and I just had it evaluated, and it gave me lots of really cool stuff. Now I put a lot of context in it, and that's kind of important to get good output. But what I did was I said, yeah, tell me the use cases, and it nailed it. I said, yeah, here's video content, analytics, blah, blah, blah. But then I said, give me some generative AI features and data model enhancements. And it did it. It said, hey, you know what would be cool is content summarization or video recommendations. And it gives you the table breakdowns and everything. And I'll show you how I did this. It's not that crazy, but it did take some good prompting. Content sentiment analysis, tag generation for videos, which I thought was really clever. And it's because each video has a tag on it for the different kind of content it is. Like, what if you could just have the AI look at the video description or something and then create some tags automatically? Great. So that is what it does. Now, I've gone down this path a few times of just using something like ChatGPT to do some work. And it's pretty cool how that actually happens. So I'm gonna show you how. Well, here's a few things that you should see in here. If we go into the test directory, there's a schema. You can play around. There's the entire killer video schema in here. If you want to play around with somebody else's schema, great. Here you go. This is a really good application schema if you want to play with it. And it works on 3.11 all the way up. And I don't think I have any SAI things in here yet. So it's pretty basic. It doesn't need to be complicated. You just need a schema for it to look at and chew on. I also have some prompts in here too, and these helper docs. And as a matter of fact, I had it do some work with this, like adding a node with no context or with context. But I have a prompt question in here that this is what I actually use to build that schema or output for that schema. It takes the docs for vector on the Cassandra website, adds that as context, and then it has this thing: your job is to create a report for end users. Here's the template, blah, blah, blah. Does all that for you. All right, I'm going to show you how that would actually work. So let's stop sharing here. And I'm going to go over here and I'm going to share some ChatGPT. Actually, what I think I'm going to do, I'm just going to share the whole window. All right. Now I'm going to take that schema. Let's take a look at the schema here. Now this is stuff that you could do immediately. So I'm just going to copy all of it. Now I'm going to go over to ChatGPT and I'm going to say, all right, you are Aaron, let me know if you can see this okay. Or if I need to zoom in more, because I know you're watching. Apache Cassandra expert. Okay, so now we've created the role. Okay. Sorry. And Apache, I love Grammarly. It just tells me how bad I am at English. You are, all right, thanks, Aaron. You are to build reports for schemas. Oops, schemas. It's live when I make those kind of mistakes. All right. Here is one to evaluate, break down use cases. Okay, and then what I do is I just paste in that whole entire schema and watch it work. And it's really cool because I don't know if you've done this before. If you haven't used ChatGPT for this sort of thing, it does work really, really well. So I'm using GPT-4. And it's been updated since I think September. So there's enough information in here to be dangerous with Cassandra. I can add context, and I will for vector, because what's funny is when we say, watch what happens when I add it to add more use cases, it's gonna show the limits of its knowledge, but we can fix that, right? And This is also probably a good thing to let's see how slow this is going. That's the LLM experience. That's why I want to minimize in an application how much interaction I have with an LLM. And I want to minimize the amount of information it has to create to respond back to the user. And these are just slow. Now, there are companies like Grok that are built a chip that is so much faster, but as it sits right now, any data that goes through an LLM is going to be like the old dial-up modem speed. But it is doing a good job. It broke down every one of the tables in the system, gave it purpose, a use case. I mean, that's pretty cool, right? And I've used this a few times to sort through. Now, again, before you go and just do this, make sure it's legally cool with your company. You do not want to get in trouble for this. And I have some other ways to do that. For instance, for DataStax, we can use Azure and use GPT in Azure for sensitive things because we have our own version of a GPT in there. That's something our legal department vetted out and said, this is cool. You can do this one thing. And we still have to ask for certain things. I'm giving you this as an example because you should be doing the same thing. You do not want to get in trouble because there's just a lot of FUD. People are afraid of LLMs and don't get in trouble. But anyway, here we are. And I'm going to say, can you recommend? I can't even spell, but this is great. I could completely misspell it and it still knows it. Yeah. It's like, I have no idea what you're talking about. So I would do this like that. Now, we have some context to give it. So what is that context? Go over to helper docs. Here's some context, this prompt question. And right here, you include the use of Cassandra vector data support. Now, what I do is I just copy the docs from the Cassandra website and use that in my prompt. So I'm like, okay, that's enough. Stop. So I'm just going to put this in. And what I'm telling it is like, okay, I want you to use Cassandra vector. Here's the docs. Here's the task, and I'm giving it context. That's something that is similar to if I would use a search or like a RAG. I'm just doing manual RAG, MRAG, but this RAG, the results that I would get would go into the context. Now I'm giving it context. I'm like, okay, here's everything about a vector database. Go use that. Watch what happens. It's like, aha. And now it's like, this is my favorite feature in ChatGPT. Now it's like, oh, I knew that. Given the comprehensive details about using vector data support in Cassandra. So it's like almost like thankful. But now it's not only giving me the answers, it's giving me code. It's giving me an alter table. That's cool. And it works. I've tested this. It does work. But I think the takeaway here is when you're in the mode of trying to figure out an implementation and you're using your existing data, you can go down this path of I want to use a vector database, or I want to add vector, Cassandra 5 stuff, or ESC or Astra, or not. And you can give it to schema and do some ideation inside here. One of the things that LLMs are really good at is being concise about taking tons of information and answering a concise question. You're like, what about non-vector RAG use cases? So it's going to think about that. And it knows what RAG is, which is cool. This is why I use, ChatGPT 4 is the best model out there right now. There are many, and GPT-4 still kind of kills them all. And that's okay. It's competition's good. Although I was going to have, we can have some fun. I also have Gemini 1.5, and Gemini 1.5 is pretty slick right now too. It does things differently, and it has different contexts inside of its own search engine history because Gemini was trained off of Google data, but it could do some really cool things too. So we'll do that real quick and have fun with it. But anyway, you can see what it's trying to do here. It's like, hey, you could do this, and here's how you can set it up. I can even have it write some of the basic code as well, but we'll get to that in a minute. But actually, right now, let's switch gears. Let's go back to what we're trying to do. Let's stop sharing and go back to sharing a window. All right, back to this. All right, so we did some stuff here. We did some hands-on. So exploring use cases. My encouragement to you is go out there and try this, and you will be pleasantly surprised at how it does work, and it can give you some good ideas. You're using GenAI to create GenAI, and it's good too because it gets you in the game. You're getting your hands on an LLM. You're understanding how LLMs work. That's important. That's very important. Okay, so what about implementations? Now, okay, we have our idea. How do we want to do this? Now, you can use LangChain and LlamaIndex right now as they are, and those are the two libraries that are predominantly for building agents in GenAI. LangChain and LlamaIndex don't completely overlap. It's worth a look at both of these, and I would love to do a deep dive into both. They are very different in a lot of ways, and more importantly is that DataStax, we have our own library called RagStack, and it's a tested enterprise version of both LangChain and LlamaIndex. We work with both of those teams pretty extensively. RagStack's open source. You can go pip install ragstack.io, and it works. It's sorry, ragstack.ai, but the link, I'll put the link up in here. I'll change that one. So there's the RagStack link that I put in the page, and it should be in the description as well. It's a great little tool. What it does is it gives you confidence to work with one of these fast-moving libraries, and that's probably the thing you have to understand is LangChain and LlamaIndex are moving fast because this industry is moving fast. And if you want something that's a little more stable that you can rely on it being tested, that's what we did with RagStax. And like I said, we're doing this in conjunction with LangChain and LlamaIndex. This is not we're not doing it adversarially at all. And it's good for them because they can move fast and we can provide a lot of help with that. And we use it inside our product quite a bit. And when we work with Cassandra, that's the other thing, is it works really seamlessly with Cassandra workloads in Astra and DSC and in open source Cassandra. So I mentioned this, like how do I get some code in this and building some prototypes? Let's go back and try this real quick. I know we're coming up on the end of the hour, but we'll do this quick. So I'm going to go ahead and share my screen once again. And we're going to see let's play with Gemini. Let's see what Gemini will come up with. I love this. You never know, right? So, all right, I'm going to go in here. I'm going to grab this page. All right. So I'm going to go back to my schema. I'm going to grab this. And I'm going to pull the schema into Gemini 1.5. And I'm going to say, here's schema. So Gemini is interesting because it has a massive context window, like 1 million, right? You could pretty much upload the entire code base for Cassandra in there. It might be expensive and slow, so don't, but here we go. But you are a Apache Cassandra developer in Python. There we go. So we just created that. You are building a RAG application using Cassandra data. Here is the schema. What would you build first? And I'm just going to give it some code. There you go. Uh-oh. I just gave it the vector search. Oops, I gave it the wrong thing. It's live. But it is kicking out a lot of stuff, huh? I'll just say stop. All right. Here's the schema. No, that's not what I want. Why is it not copying that? Fine. For some reason, I can't copy schema anymore. I have to do this. Copy. Paste. There we go. Phew. We're doing it live. Now, it's going to go through there, give me the embeddings. It's going to say use embeddings, but okay, fine. Regardless, what I want it to do, and I'm going to stop it real quick because I don't want it to completely do this. Can you write a I have no idea if this is going to work. So I'm going to Python LangChain for sentiment, video sentiment. I have no idea if this is going to work. But as most LLMs go, they're very confidently going to give you the answer. And look at that. It's creating all the code for that. So that worked. Now, I've done this a lot, and I've found that it is pretty good about coming up with prototype code. And not all of it works the way you want it to, but it's easy to tweak. It's a good way to get started. It also opens the door for something you haven't done before. Like maybe I've never done sentiment analysis with a video. Well, it gives me all the starter. Like here, use all this stuff. And it may not be exactly what I want, but it sure gets me down the road, and I can import this into VS Code or something and copy it into VS Code and make some changes. And the best thing that it can do is I can go back and say, oh, no. I want to use this library, or I want to make this change to it, whatever. And then it'll rewrite the code. So hopefully that's helpful for you as well. Now, let me wrap things up here a little bit because we're at the top of the hour. Things go fast. I always enjoy my time with you. So we're going to switch over to my other screen. And all right, so we did that. Now, the final thing that I'm going to cover is this measuring impact, and the measurements are importante. So from a measurement standpoint, the fundamentals are still there. You want to latency, throughput, errors. You need to be monitoring for that. You need to be looking at those things. And those are just fundamentals. I mentioned that because we're going to add something to it. And those new metrics are around using, say, RAG, an LLM, something like that. And those new ones are the consistency. Like, do you get the same answer every time? Relevance is just the answer that I was expecting. This precision has to do with RAG, and that's actually a measurement when it comes to using a vector databases. If I ask for compaction documentation, does it also give me everything about SS tables and bulk loader? That's a lot of noise. I want just signal. So how precise are those answers? And a lot of that comes into like how you do your vectors, that sort of thing. But precision is important because it reduces the amount of junk that it has to go through. And then recall, what is it actually getting what I need? If I say I need something about compaction and it gives me something about something else like streaming, I didn't want that. Well, the recall is poor. But those are things you can measure. And the measurement, there's some cool, really interesting, cool tools out there. LangChain, the library in the company, has LangSmith, which actually that's the name of the company, but they do tracing. And this is probably what you were looking for in an enterprise application, is tracing what happened in that call. And there's a great library out there, open source library called Ragus, which it integrates with LangSmith, a few others, LangFuse, Phoenix Rise, and OpenLayer, that it does in the library, it does all the measurements you need it to do. And that is what's going to save you in the long run. Now, what's next? So I'm coming up at the top of the hour. Easy. I need you to give me your feedback. So I have a little content poll out there. And this is super simple. It's just one thing. It was just here's a list of topics. And if you don't see it on there, then tell me what you want. And I'm going to create a lot of content, and I want to help you. So if you've seen my content before, you know that I love to dig into topics, and I would love to get deep dive, put on the scuba gear and go for it. you hopefully it's something that you need and that I can provide. So go for it, get crazy. And there's nothing on here. There's no like collecting email addresses or anything like that. So it's pretty anonymous, just a bunch of checkboxes. And then an other. If there's something not on that list, let me know. And with that, I think I'm good to go. I don't know if I have a lot of questions out there. Probably not a ton because I just poured information into you. But you all know where to find me. I'm on LinkedIn. I love InMail as long as it's not a salesperson. Use that all the time. On the ASF Slack, I'm there all the time. And of course on Twitter, Patrick McFadden. And connect with me on LinkedIn. I would love for you to let me know what you're doing. And if you have questions, I would get on a Zoom call with you, whatever you want. I'm here to help and I want to learn more about what you're up to. So thank you very much. I appreciate your time here with me today, and take my poll. I'd love to see what you're thinking. All right, everyone. Have a great day and go make something really, really cool.